Okay, so in this video we're going to talk about some of the basic geometry that you should have mastered through the year. The beginning of it. Tomorrow we'll do a little bit more. Okay, so first of all I want to talk about some line segments, and actually before we do that I want to talk about the difference between a segment and some other kind of similar related things. Okay, so if I have a line segment, that means that it's got a beginning and an ending point. Okay, and when we name line segments, we name them accordingly. We've got a little line segment above them. Okay. This is opposed to a line, which we know a line actually extends in both directions, and so you can see a line above that that has an arrow in both directions. Okay, this denotes a line, as opposed to a ray, which is sort of halfway between the two. It's got a beginning point on one end, but then extends infinitely in the other direction. So you can see it's got a little ray above it with one arrow on just one side. Okay. So we're talking about line segments. Line segments are congruent if they have the same length. So if two segments have the exact same length, we say they're congruent. And we can also talk about the midpoint of a line segment. The midpoint is right in the middle, and it divides that into two congruent segments. Okay? So if M is the midpoint of a line segment AB, then the two pieces, AM and MB, are congruent. They have the same length. And also, just to be aware that their lengths are exactly half the length of AB. And by the way, notice here I have no line segment above the letters AM. That means I'm talking about the length of that segment. Now, moving on to angles, I've got some different types of angles. One is obtuse. We know obtuse means greater than 90 degrees, acute less than 90, straight is going to be equal to 180, and right is exactly equal to 90 degrees. So we can see some examples of these. Okay. Obtuse opens up bigger than 90, acute going to be something less than 90, straight exactly equal to 180, and right exactly equal to 90 degrees. Now I want to talk really briefly about how we name angles as well. Okay. If there is only one angle at the particular vertex, the vertex being the point where the two rays intersect, okay, then I can actually just name my angle by that vertex. So if I call that, for example, O, then this is angle O. Now, if there's more than one angle at a particular vertex, or if you just want to be a little bit more specific, you can use 3 letters. Okay. So we could say that this angle is maybe ABC. Okay. And so we name it exactly that way. We use the angle symbol, and then we say ABC, noticing that the vertex is always going to be the middle letter. Okay. So that's 2 ways we can measure it. We can name an angle. We can also name an angle with a number. If I've got a number somewhere in that angle, then I can say that this is, for example, angle 1. Okay. Just one more note on angle measures and denotations. I can say that an angle is right if I've got a little box inside the angle that tells me that it's definitely a right angle. Now, talking about some angle relationships, complementary angles. Now you see this little box tells me that that big thing is a right angle. So these two angles, 1 and 2 together, make a right angle, which means that they add up to 90 degrees, and that's exactly what complementary means. Okay. Supplementary here, in this case, angles 1 and 2 add up to a straight line, okay, or a straight angle, which is 180 degrees. So supplementary means that they add up to 180. And then vertical angles happen when two straight lines intersect. Okay? The angles that are on opposite sides of each other are the same measure. They're congruent, so the measures are equal. Okay? All right, so that's some angle relationships. And now I can talk about some word problems, and I can use that information. So one angle is 20 degrees more than its supplement. I want to make sure that I'm always defining my variable, so I say x is the angle. Okay. And I also care about the supplement. So if the two angles together have to add up to 180, and x is one of them, then the supplement of the angle must be 180 minus x. So now what I'm going to do is I'm just going to take this sentence here, and I'm going to translate it into an equation. So we start with one angle. Okay, so the angle we said was x, the measure of the angle, is, that's always an easy one, means equal to 20 degrees more. So I'm going to be adding 20 to something, and that something is the supplement, which we said was 180 minus x. So there we have it, translating a sentence into an equation. And now my job is easy. All I have to do is solve the equation. So I can add x to both sides here. So this is going to give me 2x is equal to 180 plus 20, which is 200. And divide by 2, so x is equal to 100. Do make sure at the end that you're answering the question. The question says 2 angle measures. Make sure you've got both of them. Not just the angle, but also the supplement I'm looking for. So 180 minus x is going to be 180 minus 100, which is 80 degrees. So there are my 2 angles. Moving right along, I can talk briefly about isosceles triangles. Isosceles triangles, we remember, means that they have 2 congruent sides. So I can mark that in my picture here, say that those 2 sides are congruent. And kind of a side effect of this, if I have 2 congruent sides, I also have 2 congruent angles. So these 2 angles down here are also the same measure, and we call them base angles. Okay, moving right along. Parallel lines cut by a transversal. So if I know that these 2 lines are parallel, and we can mark that by putting little arrows on the lines, means they're parallel, and I've got this transversal running through them, lots of angle relationships here. First of all, corresponding angles. Corresponding angles happen when I take one, or imagine taking one intersection, and kind of dropping it down right on top of the other. Corresponding angles are going to be ones that line right up. So for example, 1 and 5. Okay, that's not the only pair, of course. We also have 2 and 6, 3 and 7, 4 and 8, okay, but we're just going to be writing 1. And what you might notice about 1 and 5 here are that they look pretty much the same size, and in fact they are. So another thing that we know about corresponding angles is that they are congruent to one another. Moving right along, alternate interior. Alternate means opposite sides of the transversal, and interior means inside the parallel line. So alternate interior are going to be, for example, 4 and 5, or 3 and 6 also are alternate interior angles. Okay. And those guys, if you'll notice, also look pretty similar, and they are also congruent, you should remember. Next, alternate exterior. So again, alternate, opposite sides of the transversal, but outside the parallel lines, exterior. So for example, 1 and 8 or 2 and 7 also are alternate exterior. And once again, you can see that they are the same measure. Now, same side interior. Same side interior means I've got, say, 1 here, and also interior, but on the same side of the transversal. Now these guys, you notice, don't look the same, 5 and 3. Okay, but they do have a special relationship. If you remember, 5 and 4 were the same, and 4 and 3 are on a straight line together, they're supplementary, which means that 5 and 3 are also supplementary. Okay, so that's going to be true of all same side interior angles. And then finally, same side exterior, so same side of the transversal, but outside the parallel line, so for example, 1 and 7 or 2 and 8. Okay, and again, they don't look the same, but they turn out to be supplementary. So, moving right along, I can find the values of some missing angles in this picture here. Okay, I've got 2 lines that are parallel, and so let's start talking some angles. 65 degrees. Now the first thing I'm seeing is that I've got these 2 marks here, which tell me that this triangle is isosceles, and so the base angles are congruent, 65 and 2. So the measure of angle 2 must also be 65 degrees. Okay. Now next thing I'm seeing is that 65 and 5 are corresponding in these 2 pairs here. So angle 5 also congruent to that 65 degree angle. And while we're in this vein of 65 degree angles, 2 over here and 4 over here are vertical angles. And so that one is also 65 degrees. Next, I see this angle 3 here. Now it's not congruent, but it's on a straight line. It's supplementary to 2. So if I can subtract 65 from 180, I'm going to get angle 3, which is 115 degrees. And angle 6 is alternate exterior angles with angle 3, so that's also going to be 115. Okay. The last angle we need to talk about is actually the first angle on my list, which is angle number 1. Okay, and we're going to get to a theorem in just a second that says that in a triangle, any triangle at all, the 3 angles add up to 180 degrees. That's something you might remember. So if I've got these 2 angles down here are 65 degrees each, together they make 130 degrees, and so that leaves me 50 degrees out of my 180 for angle 1. So just to reiterate, the measures of all the angles, if I add them up, I should always get to 180 degrees in a triangle. So for example, in this next problem, I've got 3 angles of a triangle as variable expressions. And so if I want to know what x is, I have to add them up. 2 times x plus 15 plus x plus 10 plus 2x and that sum of all those angles has to be 180 degrees. So I can distribute my 2 in here. We get 2x plus 30 plus x plus 10 plus 2x equals 180. Combine some like terms, 2x and an x and another 2x are 5x. 30 and 10 gives me 40. And then I can subtract 40 on both sides, so that's going to give me 5x is equal to 140. And then divide by 5, and so we get x is equal to 28. It's a little fast. Sorry about that, guys. We must forge ahead. So next problem, 3 angles of a triangle are consecutive even integers. We should remember that from a previous video. Consecutive even integers we know count up by 2's. So if x is my first integer, then the next even integer is going to be x plus 2, and the next one after that is going to be x plus 4. So here are my consecutive even integers. Now, they're the 3 angles of a triangle, and so I know that if I add them up, x plus 2 plus x plus 4, I should get 180 degrees. So combining like terms, 3x plus 6 equals 180. Subtracting 6 on both sides, 3x is equal to 174. And then dividing by 3. So that's going to give me x is equal to 58. Now make sure that you're always answering the question, asks for all 3 numbers. So x is 58. I also want x plus 2, which is 60 degrees, and x plus 4, which is going to be 62 degrees. So here are my 3 consecutive even integers that can be the angles of a triangle. Okay. Next, exterior angles. Now an exterior angle in a triangle means that I take one side of the triangle and I just extend it out beyond the triangle. So the exterior angle is the angle that's formed outside that triangle. And that measure is going to be equal to the sum of the 2 remote interior angles. Remote meaning far away. So not the one immediately next to the exterior angle, but the other guys out here. So if I add those up, that sum should be equal to the exterior. So 3x minus 10 is equal to 25 plus x plus 15. And we can solve this. Subtract x both sides. So 2x minus 10 is equal to 25 and 15 is 40. Add 10 to both sides, 2x is equal to 50, and divide by 2, so x is equal to 25. All right, one last bit. I want to talk about congruent triangles. Now, if you remember, there were 3 sort of postulates, if you will, that we used to prove triangles congruent. We had side, 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 and angle, side, angle. Okay, I always need 3 pieces of information. I can have all 3 sides. I can have 2 sides and the angle in between them, or 2 angles and the side in between them. Very important. Now, looking at example A here, I definitely have 2 triangles. I've got an angle and a side in each, but that's only 2 pieces of information. That's not enough, you might be thinking. Okay? But there are some things that I can take just from the picture. For example, I see that these 2 angles here at C, they're vertical angles, and so they must be congruent. So that means that I actually have an angle, a side, and another angle in each triangle. And so these 2 guys are congruent by angle, side, angle. Similarly, in the second triangle, you might say, well, we only have 2 pieces of information, 2 sides. It's not enough. Okay? And I don't know anything about any of the angles. Nobody told me anything. But what I can see is that this line segment QY is actually shared in both triangles. So of course it's the same length. It's the same segment. When we do that, when we use the same segment in both triangles, we call that the reflexive property. Okay, if you remember reflexive property, you can think reflection in the mirror. It's exactly the same thing. And so I do have 3 sides. These 2 triangles are congruent by side, side, side. Finally, in this last pair of triangles, okay, again, you might say, well, I don't have 2 angles and the side in between them, right? I would need to know CA and ZY to be able to prove this by side, angle, side, angle, side, angle. Okay, I don't have the side in between. Fortunately, we do know, though, that the three angles in a triangle have to add up to 180 degrees. So if two of them are 75 and 65, that adds up to 140, leaving me exactly 40 degrees for angle B. And similarly, 40 degrees for angle X. So I do have one pair of angles, one pair of sides, and another pair of angles where the side is in between the angles that I know, and so this guy is also angle, side, angle, and I can prove that they are congruent. Okay, so that's all the basic geometry we're going to need for the final. We're going to talk a little bit more about some other geometry concepts a little bit later, like areas and perimeters and things like that, but we're good for today.